The cosine rule. As discussed in the previous topic, to solve problems involving triangles which are not right-angled, we can use the sine and the cosine rules. While the previous topic focused on the sine rule, in this topic we will focus on the cosine rule. We can use the cosine rule to find a side when we have two sides and the angle between them. So in the triangle shown on the right hand side, if we want to find the length of side A, we can use the cosine rule if we have side B and side C and the angle between them, angle A. The cosine rule states A squared equals B squared plus C squared minus 2BC cos A. Now notice these are the same values needed to calculate the area of a triangle. For the area of a triangle, half AB sine C, or in our case half BC sine A, we also need two sides and the angle between them. So we can use the cosine rule to find a side when we have two sides and the angle between them. But we can also use the cosine rule to find an angle when we have all three sides. So looking at the triangle again, if we have all three sides A, B and C, we can rearrange the cosine rule to give us cos A equals B squared plus C squared minus A squared over 2BC. Now note, these three formula are provided in the formula sheet of the exam: the sine rule, the cosine rule and the rearranged cosine rule. In our first couple of examples, we will show how we can use the cosine rule to find the length of a side. So our first example, we're asked to calculate the length of side CB to two decimal places for triangle ACB. So ACB has a side length AC of 5 centimeters, AB of 7 centimeters and angle CAB or angle A of 85 degrees. So the first thing we want to do is label the sides. Side A is opposite point A, B is opposite point B and C is opposite point C. Now looking at this, we can see that we have two sides and the angle between them. We have side B and side C and angle A, which is between side B and side C. So we can use the cosine rule. So let's substitute these values into the cosine rule. So we get 5 squared plus 7 squared minus 2 times 5 times 7 times cos 85 degrees. Now when using a calculator, we would probably do the following few steps all in the one go. However, for demonstration or display purposes, we'll break this down. And this gives us 74 minus 70 times cos 85. A squared equals 67.899 and a number of decimal places after that. And taking the square root of this gives us A is equal to 8.24 centimeters to 2 decimal places. As stated, when doing questions like this, it's best to do the full calculation in your calculator, taking the square root, and that way we don't lose any degrees of accuracy through our calculation. Okay, in our second example, we're asked to calculate the length of side PR to one decimal place. We are given PQ as 8 centimeters, QR as 3 centimeters, and angle PQR is 120 degrees. So again, first we label the sides. P is opposite point P, we have R, and we have Q. And Q is the side that we want to find. Again, we have two sides and the angle between them. We have R and P and angle Q, so we can use the cosine rule. However, we have to tailor the cosine rule for our question. We want to find side Q, which is, so our version of the cosine rule will be Q squared equals P squared plus R squared minus 2PR cos Q. Now, this shows the reason why we want to label the sides. When we label the sides appropriately, we can work out the version of the cosine rule that we need to use for our question. So we want to solve for Q. So Q squared equals P squared plus R squared minus 2PR cos Q. Now let's substitute in our values. 3 squared plus 8 squared minus 2 times 3 times 8 times cos of 120. Q squared is equal to 97. Taking the square root of 97, we get Q equal to 9.8 centimeters to 1 decimal place. So we can use the cosine rule to find the length of a side when we have two sides and the angle between them. Now let's look at how we can use the cosine rule to find the size of an angle. In our first example, we're asked to calculate the size of angle CAB to 1 decimal place. So we have triangle ABC as shown. AC is 5 centimeters, AB is 7 centimeters, and CB is 8.24 centimeters. So let's first label the sides, as we should always do. Side A is opposite point A, side B is opposite point B, and side C is opposite point C. Let's also mark on the angle we've been asked to find, which is angle CAB or angle A. From the diagram, we can see that we have 3 sides, so we can use the rearranged cosine rule to calculate the size of angle A. Cos A equals B squared plus C squared minus A squared over 2BC. Plugging in our values, we have cos A equals 5 squared plus 7 squared minus 8.24 squared over 2 times 5 times 7. So cos A is equal to 0.0871 and onwards to a number of decimal places. We then need to take the inverse cos of both sides to get A on its own, and this gives us A is equal to 85 degrees. As before, we normally do the last 2 steps in our calculator in the one go, but we've broken it out here for display purposes just to show you that we take the inverse cos of both sides. Okay, in our final example on this topic, we're asked to calculate the size of the smallest angle in triangle XYZ. Now, as always, first we label the sides. So we have side X, side Y, and side Z. And the next question we need to ask ourselves is, which is the smallest angle in the triangle? We do have 3 sides and we can use the cosine rule to find the angle, but which angle is it that we need to find? Now, the smallest angle in a triangle will be opposite the smallest side, and conversely, the largest angle in a triangle will be opposite the largest side. So the smallest side for us is side XY or side Z, which is 6.3 centimeters. So we need to find angle Z. So we use the variant of the cosine rule, which is applicable for cos Z. So cos Z is equal to x squared plus y squared minus z squared all over 2xy. Let's substitute in our values. We have 7.2 squared plus 8.5 squared minus 6.3 squared all over 2 times 7.2 times 8.5. Cos Z is 0.689 and onwards. Taking the inverse cos gives us Z equal to 46.4 degrees to 1 decimal place. Okay, so that's it for our topic on the cosine rule. We've explored how we can use the cosine rule to find the length of an unknown side and how to use the cosine rule to find the size of an unknown angle. As always, it's now time for you to practice.